Okay, so we find out the solutions. The solution to the Hermite differential equation. One of the solution as y1 is equal to some c naught 1 minus 2n by 2 factorial x square plus so on. Uh, Last term is minus 2 raised to power m n into n minus 2 so on up to n minus 2m minus plus 2 divided by into x raised to power 2m divided by 2m factorial divided by 2m factorial plus there will be the other terms. Okay, and the another solution corresponding to y2 is c0. लास्ट में जो फाइंड किया है x minus 2 into n minus 1 divided by 3 factorial x raised to power 3 plus 2 raised to power 2 then n minus 1 n minus 3 divided by 5 factorial x raised to power 5 plus so on. Similarly, I will write down the general term n minus 2 m minus 1 जो मैंने अभी फाइंड किया था. So we have find out these two the solution to the Hermite this polynomial. This Hermite differential equation. Okay, now I will say that if n is an even integer in this equation, if n in the first case, if n is even integer and it will take only the even values and the c naught is equal to minus 1 raised to power n by 2 minus 1 raised to power n by 2 n factorial divided by n by 2 factorial, right? Instead of 2m I am going to write it as n. I am going to write it as n. 2m is equal to 2m is equal to n. Okay, then m will be equal to n by 2. Just I am making that. So similarly we have here minus 1 raised to power m. So यहाँ पे that's why I will take it as minus 1 raised to power n by 2 n factorial because 2m यहाँ पे आ जाएगा आपका. Okay, so in the denominator we have 2m factorial. 2m will be equal to 1 minute. Okay, so the last term. So what could be the last term then? So the last term from this equation, I will write down this as it will simply will be equation. The yani the term I will write here the term containing x raised power n in y1. X raised power n यानी x raised power when 2m equal to x raised power n जो यहाँ पे है 2m is equal to n. So the term containing x raised power 2m will be equal to c0 क्या है आपका? C0 is simply minus 1 raised to power n by 2. I am saying n factorial divided by n by 2 factorial. Okay, so now this will become minus 2 raised to power m is n by 2 n into n minus 2 so on n minus 2 plus 2 n minus n 2m is n, so it will be m minus m n minus n. यहाँ पे आप यही देखिए जहाँ पे मैं 2m यूज कर रहा हूँ ना 2m के बदले में x यूज करूंगा ना 2m के बदले में n यूज करूंगा. So this is 2m is n divided by now 2m is simply n factorial. Okay, 2m is my n factorial, then it will be x raised to power n. X raised power n. Now if you look at all these terms, they will just cancel out and we will just have a 2. So यहाँ पे जैसे n और n आपका cancel हो जाएगा. n minus 2, this is n factorial will get cancel out with this 2 factorial. n by 2 factorial minus 2 raised power n. जब आप ये multiply करेंगे सारे चीज, so you will get only 2x raised to power n. From all these terms, we will have the 2x. Yani when I am making this coefficient C0 equal to this minus 1 raised by n by 2 n factorial divided by n by 2 factorial and then substitute then the last term will now become simply 2x raised to power n. यहाँ पे ये सारी वाली terms आपस में they will just cross terms, they will just get cancel out and we will have 2 instead of all these things and we x raised power 2 raised power n rather 2 raised power n by 2 है ही हमारे पास. So this will be 2 raised power n. As a result we will get 2x raised power n. ये थोड़ा देख लेना खुद से solve करके. Okay. Similarly, I will have the coefficient of the another term. Similarly, the coefficient of कोफिशिएंट ऑफ x रेज पावर n minus 1. x रेज पावर n मैंने कहा था in y1, x रेज पावर n minus 1 क्या होगा अब? Now coefficient of x raised power n minus 1 will be equal to minus n into n minus 1 divided by 1 factorial 2x raised power n minus 2. यानी next term the coefficient this is n, इससे पहले वाली term that is n minus 1 वाली term, उसके बाद n minus 2 वाली term, इसके बाद n minus 3 वाली term आ जाएगी and so on. यानी द नेक्स्ट टर्म फॉर एग्जांपल कोएफिशिएंट ऑफ x रेज पावर n minus 2 वाली टर्म का क्या हो जाएगा? इट विल बी माइनस n, सॉरी प्लस वाला आ जाएगा, ये प्लस n into n minus 1 into n minus 2 into n minus 3 and divide by 2 factorial into then 2x raised to power n minus 4. We are taking this even integer only, x raised power n minus 4. Similarly, so what could be this solution? So this solution, जो solution y1 है, see this solution, now this solution y1 will now become, okay, I will just write down the last term. So instead of last term, when you are going to multiply it with c0, ये क्या बन जाएगी आपकी 2x. So I will write down this as 2x raised to power n, okay, minus the second term n minus 1 term, the minus term it is n into n minus 1 divided by this 1 factorial, then 2x raised to power n minus 1, sorry n minus 2. Similarly, plus the next term जो ये वाली term है, it will be n into n minus 1 into n minus 3 into n minus 5 divided by 2 factorial, then x raised power 2x raised power n minus 4. So this is the solution y1. ये आपका solution same ही है जो मैं यहाँ पे लिख रहा हूँ, except now I am substituting the value for n c1 here. ठीक है, and I'm just making 2m equal to n. So when I'm making this, I can write down the solution to this differential equation. You just name this as some equation 1 because I will just combine these two equations. Okay, now similarly, when n is odd, when n is odd, अब जब n आपका odd होगा, so what will be the coefficient c naught? From here, the coefficient c naught when n is odd, when n is odd, the coefficient c naught will now simply be equal to minus 1 raised to power n minus 1 by 2, right? Then n minus 1 factorial, यहाँ पे आप देखो, divide by n minus 1 by 2 factorial. Simple. Okay, now similarly I will have these terms, the coefficient c1, c2, c4. So this the solution y now will be equal to 2x raised to power n, the first term, c0, because it will be again 2 raised to power n minus n into n minus 1 divided by 1 factorial into 2x raised to power n minus 2, यहाँ से देखिए n minus 2 plus so on some other terms. This is y. Okay, you don't need to write it y1. I will just write simply this as a y, solution y. Okay, 2x raised power n, then 2x raised power n minus 2, these two terms. So the values of this y, so name this as equation 2. So the values of the y in equation this and this, these are called as a Hermite polynomials. We call them as Hermite polynomials. Okay, so they are called Hermite polynomials of degree n for even and odd integers. I will just combine these two equations in one single equation so that you can obtain all the Hermite polynomial from that very equation. So in order to do that, let me write it on the next page. Okay, so this Hermite polynomial, usually we represent them as this hn of x. Instead of writing for it separately for even and odd, I will write down this as hn of x is equal to some summation m running from 0 to p, some value, minus 1 raised to power m n factorial divided by m factorial into n minus 2m factorial, then 2x raised to power n minus 2m, n minus 2m. Okay, so where this p is equal to n by 2, यानी the summation is taken up to the n by 2, जो मैंने अभी केस लिया था, for even values, for even, and p is equal to n minus 1 by 2 for odd. यहाँ पे आप देखिए, यहाँ पे मैं n ले रहा हूँ, p is equal to n by 2, यहाँ पे n by 2 और यहाँ पे n minus 1 by 2. So वही चीज मैं यहाँ पे कह रहा हूँ कि this p is taken for, so we can have two different values for odd and even. So when p is equal to n by 2, we are getting for it for the even values, and when is n is equal to odd, when n is equal to odd. So let us try to find out the sum of the Hermite polynomials from this very equation. Okay, now n is 0, for example. So what is h0 of x here? Can you tell me? So 0 is even, so it will be summation will be 0 to n is 0, so it will be 0 to 0. I'm not bothered about, so minus 1 raised to power m, this is m is again 0, n factorial minus 1 raised to power 0, it will become 1, n factorial is 0 factorial divided by m factorial into 0, this again becomes the 0 factorial because m will run from 0, so 0 factorial into n minus 2m, that will become 0, then 2x raised to power n minus 2m, so n is 0 minus 2m, this is 0, so all these things will become 0, 0 factorial divided by 0, so it will simply be equal to 1. Okay, now similarly, what is h1 of x? H1 of x odd, so summation will go from, let me write it, so summation will go from m equal to 0 to m is odd, 1 to odd, है कि नहीं? So the p summation is p, n is 1, 1 minus 1, so summation will go from 0 to 0. Okay, now minus 1 raised to power m, m is 0 to 0, we have to take up only one term, so this is minus 1 raised to power 0. Okay, n factorial, that is 1 factorial, then again m is 0 factorial into n 1 minus 2 into 0, that is 0 factorial, it will become 1 factorial. Then here we have 2x raised to power n is 1 minus 2 into 0, so this will become 1 minus 0. Okay, so this is 1 0, all these things 1, so it will simply be equal to 2x, right? So this h1 of x will be equal to 2x. So these are Hermite polynomials, h0x, h1 of x. Similarly, you can find h2 of x. What is h2 of x now? Now h2 of x will be summation will running from m equal to 0, p is equal to 2. Sorry, p is equal 2 is even, so the summation will be n by 2. n हमारे पास क्या है 2, 2 by 2, so summation will run from 1, 0 to 1. So so we will get 2, 1, एक में आपका m equal to 0. So when m equal to 0, so it will be minus 1 raised to power 0, n factorial is 2 factorial divided by m factorial is 0 factorial into n is 2 minus m is 0 factorial, this is 2 factorial. Okay, then we have the 2x raised to power n is 2 minus 0 plus the second term when m is equal to 1. When m will be equal to 1, this will be now m equal to 1, so it will be minus 1 raised to power 1, n factorial is again 2 factorial divided by m factorial is 1 factorial into n minus 2, n is 2 minus 2. Okay, so this will be now 2x raised to power n is 2 minus m is 2, m is 1, so 2 ones are 2, so this is 2x raised to power 0. So this here it will be, ये आपका 2 factorial यहाँ पे हो जाएगा, 2 minus 0, that is 2 factorial, this 2 factorial, 2 factorial cancel, it will be 2x raised to power 2, that is 4x square minus, यहाँ पे क्या रह जाएगा आपका 4x square minus, यहाँ पे 2 2 0 factorial, so this is 0, 2 minus 2 is 0, यहाँ पे खाली आपका 2 रह जाएगा, 4x square minus 2. Similarly, you can find out h3 of x, then h4 of x. So you just find out, you find out these values also, h3x, I have find out one these values, so h3 of x में आपका क्या हो जाएगा? Now similarly in h3 of x the summation will run from n minus 1, n is 3, that is 2, so we will have the two different for h3x. Again we will have in h3x we have two terms, but in h4x में कितना हो जाएगा? h4x में आपका है n by 2, n is 4, 4 by 2, that is, so the summation will be 0, 1 and 2 because the summation will run from 0 to 2. So I will write here, you just h3 of x will be equal to some 4x into 2x minus, and let me write it like this. It will be 8x square minus 12x 12x, yeah, h3 h4 of x फिर आपका आ जाएगा 16x4 minus 48x square plus 12 plus so on. Sorry. Okay, so this is about the Hermite polynomials. You do concentrate on this this Hermite polynomial. This is what we get from the solution to the Legendre. Actually, we were supposed to start from this very point, because in our seminar we have the Hermite polynomials. We are not supposed to find out the solution, but I first showed you how we can find out the series solution. From the series solution, we are actually generalizing the two terms for two different values. Either n is odd or even, and then we combine them into one single equation, what we call as a Hermite polynomials. So you can obtain all the you have to remember this particular equation to obtain all the Hermite polynomials. Okay, so now these, as I said, these Hermite polynomials will be very useful once you will solve this harmonic oscillator problem in the quantum mechanics. You will see there, you will be asked to find out these Hermite polynomials for that very problem. So in the solution, so I know you have understood up to the solution very well, like I find out y1 and y2. So from the y1 and y2, I make two different substitutions. I am taking this value of the c naught and just making the coefficient of this the term x raised power n, right? जहाँ पे मैं c naught, so c naught, when n is even, I am taking like c naught equal to n by 2, and when n is equal to, it is n minus 1 by 2 terms. Okay, so both those equations will arrive at this particular equation, जिसको हम combine करके फिर ऐसे लिखेंगे. So this equation is used to find out the Hermite polynomial. For example, you will be asked to find out the h100 of x, 100th polynomial. Obviously, it will be very difficult to you. It will contain the 100 polynomial. 100 is even, so it will be summation m running from 0 to 50. Because 100 by 50, it will contain the 50 terms, but we can make some program and in C or in some photon, and we can obtain all those terms, 50 terms, but provided you know this Hermite, the Hermite polynomial equation. This is what we call as a Hermite polynomial equation. Hermite polynomial equation. Okay, and we call them as a Hermite polynomials. Is it okay? Okay, now we have still the next lecture will be about these Hermite polynomials also. We have to find out the orthogonality conditions of these Hermite polynomials. Then we need to find out the reconciliations and also the generating function for these these polynomials. So that will be inshallah done. We will do that in the inshallah in the next lecture. So next lecture will again be about this Hermite polynomials. Then we will move to the Leguer. So I wish by before this year we will end this unit, and we will inshallah, because we have some 3-4 lectures, and we, within those 4 lectures we will do it.